Hello, my name is Sean Sullivan. This video is for IDS210 at Whatcom Community College, Project 1. For my first project, I decided to look into electricity. I spent 7 years working in solar manufacturing, so I have a lot of experience with the assembly of electric components, but not so much with the real magic, so to speak, behind it. So this is something that I was really interested in and that I wanted to do. So for my project, I decided to endeavor to create a Voltaic pile battery, which is what you see before me. Now, before I get into the battery itself, let me go over the materials that I have for this project. So for this project, I am using pennies and nickels. Those constitute the metals that are dissimilar. So the penny is acting kind of towards the zinc, the nickel obviously is the dissimilar metal. Okay, so I'm using pennies and nickels. I'm also using aluminum foil, as you can see. I'm using note cards that have been cut into small circles and that have been soaked in vinegar and salt. So this is just a very basic experiment, right? I also have a little LED light here. And so what we have is what's known as a voltaic pile or a voltaic column. It consists of alternating discs of zinc and silver. In this case, we've got pennies and nickels, separated by paper that has been soaked in a specific solution. In this case, I'm using vinegar and salt. The vinegar and salt with the paper creates the electrolyte, and the electrolyte is what we're looking at here. The electrolyte is actually what facilitates the electricity between the dissimilar metals and the tinfoil. Getting into this project a little bit, what's supposed to happen is when I take my little LED light here and apply one end to the tinfoil and one end to the top, I'm supposed to get a light. Oh, and there we go, it all falls down. Unfortunately, I have not been able to get this to work. So I think it's a combination of a few factors. Number one is that, using this type of experiment requires some tweaking. I've been working on this for a few days now, and I just haven't quite been able to get it to the point where I actually get a charge. I also don't have a multimeter here with me, which obviously means I can't check if it's even creating a current. So a little frustrating. I was really hoping that this project would have turned out a little better. But I can definitely say, in conclusion, that this is not a very effective form of electricity, and it's not something that I would pursue or recommend for anything that's important. As a fun little experiment at home, absolutely. Some things that I might try in the future is I might try to kind of improve the setup a little bit. I might try to make make it a little more presentable. Really might try to work down just to the specifics of what materials I need. The pros of this project is that it's very simple, it's very easy to do. The cons, it's not very effective. So when looking towards electricity, I think it's important to remember that, there is simplicity in it, right? And, you can do very simple projects, but I think it's also important to remember that, on a mass scale, I think that electricity is something that we already rely on, and it's something that we're going to rely on increasingly. And so I think that in the future, exploring, like the EV industry and all the milestones that we've seen there, I think that innovation into how do we generate electricity is going to be the answer, as opposed to just, nuclear power plants or burning fossil fuels to create electricity. I think it will be, fundamentally, it will be a different source. So I can say that I had fun with this project. Unfortunately, it did not work, but I can say conclusively that this is not a reliable form of energy, and you should not pursue this for anything that is important. So thank you all for watching. I'm excited to continue with this class and see what we can come up with and see what kind of experiments we can conduct. So thank you very much. Take care.